talk about operation relationships. So, the first ones we want to talk about are addition and subtraction are opposite operations. So if I start with a number and I add something to it, then take that number away, I start with the beginning number. So that is 5 plus 2 minus 2 gives me 5. Notice how these middle numbers are the same numbers. You add something, then take it away. You have not changed anything. Moving on to the next one. 16 minus 3 plus what gives me 16? 3. Again, those two numbers match each other. Notice how the outside numbers also match. Next one, 24 plus 5 minus what gives you 24? 5. The insides match, the outsides match. Division. Okay, so multiplication and division are opposite operations. Very similar to what we did up with the adding and subtracting, we will do the same thing with multiplying and dividing. So if I start with 8 and divide by 2 and multiply by what number would I end up with 8? 2. Again, the insides match and the outsides match. If I start with 15, multiply by 3, divide by what number, and I end up with 15, what goes in the blank? 3. And what number would I start with, multiply by 10, divide by some number, and end up with 36? 36 times 10 divided by 10. Again, insides, outside. Okay, now moving on. Repeated addition is also multiplication. Okay, so we're going to rewrite these examples using multiplication. So 3 plus 3 plus 3 plus 3. What is another way of writing that? 3 times 4. Could I also write 4 times 3? Yeah. Yes. So I counted how many of them there were. There were 4 of them, and pretty much this last section gives me my answer. So if I count the 5s, there are 2 of them. And again, this last section gives me my answer. 5 times 2 or 2 times 5. Okay, so 1, 2, 3, 4, 5 K's. So 5 times K. You don't need the multiplication sign between a variable and a number. And I'm just going to keep it as 5K instead of K5. It's okay to write that, but you will more so see it with the variable being behind the number. And E's, 1, 2, 3, 3E. Okay, repeated subtraction is also called division. Notice how none of these answers or none of these problems have actual answers. I didn't add anything, I didn't multiply anything. All I did was rewrite it by applying the repeated operations. So 48 minus 8 minus 8 minus 8 minus 8 minus 8 minus 8 minus 8. So I'm going to count how many 8s there are. And this time I'm going to connect this with this. 48 divided by 8 equals 6. So I'm going to count those fours. 1, 2, 3, 4. 16 divided by 4 equals 4. We're going to make up this last one. What do you want to take away from 10? 5. 10 minus 5 minus 5, right? 1, 2. So 10 divided by 5 equals 2. Repeated multiplication is also called an exponent. Okay. So again, it's about counting 1, 2, 9 to the second power. And you got to make sure that it's a superscript number in the upper right-hand corner. And you get it by counting. 1, 2, 3. 2 to the third power. 1, 2, 3, 7 to the third power. 1, 2, r to the second power. You're going to see a lot of variables throughout this whole entire unit. Variables are those letters between A through Z. And 1, 2, 3, 4. So w to the fourth power. This is a bad example of why we don't like to use x's as multiplication signs anymore, because it's misleading. We should have used dots between them, because x's can be variables. Okay, so the first part is what can I fill in the blanks with to make the number sentence true? 4 plus 5 minus blank equals 4. 5. So the insides and outsides match. Next one, 25 minus what plus 10 gives you 25? Insides, outsides. Next one, what number plus 16 minus 16 gives you 45? 45. Insides, outsides. 56 minus 20 plus 20 gives you 56. Insides, outsides. A plus B minus what gives you A? B. Insides, outsides. C minus D plus D equals C. E plus what minus F equals E? And what minus H plus H gives you G? G. Okay, so we are going to just focus on the top box. I don't even need a tape diagram, so you can go ahead and cross this off. Okay, so I'm going to count how many x's there are here. This matches with the number that's at the end of the statement here. So 12 divided by x equals 4, and x would be 3. So I'm going to rewrite this statement. 18 minus how many x's? 3 x's. And that 3 comes right from there. And it's always going to be 0. So 18 minus what number, minus what number, minus what number would end up with 0?
3.
No.
2. 8. 9.
6. 18 minus 6, minus 6, minus 6 gives you 0. The next one. 35 minus how many x's?
5.
Well, actually, this is y's. These are y's, sorry. 1, 2, 3, 4, 5. Don't forget to set it equal to 0. And what is the value of the y's? 7. Okay, and the last one, how many z's will I subtract? Minus z, 2, 3, 4, 5, 6. Remember, set it equal to 0. And what's the value of each z? 7. And in case you're wondering if you're doing it correctly, if you take what it said it equaled at the beginning and what you say the value of the variable are and multiply those, you will get your beginning answer. 6 times 7 is 42. 5 times 7 is 35. 3 times 6 is 18. And 4 times 3 is 12. It's a double check.